Okay, so we're going to do a vector problem. And in this problem, we're given a vector with a magnitude and a direction. And so we're going to write our givens. Right, so for every problem I do givens and finds. Great way to start a problem. So r is equal to 100 meters and theta is equal to 45 degrees. And my find values are x and y. So let's draw a little picture. So that's going to be my r. This is going to be my theta. And what I'm looking for is y and x. Okay, so this is A. So I have 3 parts to my problem. So I'm going to do this for 3 different examples. So if I want to find x, x is right here. So x is adjacent to the angle, so I'm going to use cosine. So cosine theta is equal to adjacent over hypotenuse. Right, my adjacent is x and my hypotenuse is r. So that's going to equal x over r. And so if I want to get x alone, this is what I'm trying to find, I'm going to multiply both sides, both x over r and cosine theta by r. So I get x is equal to r cosine theta. And if I plug in, x is equal to 100 meters times cosine of 45. And so x, plug that into my calculator, and I get 70.7 meters. Want to do the same thing for y, so I can use sine. So I'm looking for, this is y is opposite, and r is hypotenuse. So sine theta is equal to opposite over hypotenuse, or y over r. Right, so I'm going to multiply this side by r, I'm going to multiply by r sine theta by r, or sine theta by r, and I get y is equal to r sine theta. And I expect this to be the same, right, because my theta is 45 degrees. So I know sine theta and cosine theta of 45 degrees are the same, so I expect the same answer, but we'll just check 100 meters and then sine of 45. And when I plug that in, I get y is equal to 70.7 meters. We're going to move on to B. And by the way, I want to box my answers here. Practicing our problem solving strategy. So B is my given is that the velocity is equal to 300 meters per second and theta is equal to 20 degrees. My finds, trying to find Vx, V sub x, so the x and y components of the velocity. Draw a little picture. My V is 20 degrees, so it's a little not as steep. So this is going to be V, and this is going to be my Vy, and this on the x-axis is going to be my Vx, and this is my theta. So I'm going to do the same thing. Looking for Vx first. So that means just from above, I had cosine theta, so I'm going to use cosine theta again. So I can use the same idea, the same equation, x is equal to r sine theta. Well, we're going to do Vx, right? So Vx is adjacent, so that means I'm going to use V cosine theta, and Vy, just like over here, my sine theta is equal to y over r. I'm going to do sine theta is equal to Vy over V. So then Vy is going to be V sine theta. So plugging in numbers, my Vx is going to equal 300 meters per second times cosine 20. My Vy is going to equal 300 meters per second times sine of 20. When I plug these in, I get Vx is equal to 281.9 meters per second, and Vy is equal to 102.6 meters per second. Okay, for part C. So part C, we're given an acceleration. So an acceleration is equal to 5 meters per second squared. And it tells me that it's only in the y direction. Okay, and so that's my given. And my find, I'm trying to find AX and AY. And I'm sorry, this is actually, it's only in the negative X direction here. Just double check on that. It's actually only in the negative Y direction. So only in the negative Y direction. So let's draw, oops, I'm still on eraser, in the negative Y direction. So I'm gonna just draw that. Okay, so I'm drawing A here, and so if A is 5 meters per second squared only in the negative Y direction, that means I'm gonna have, that's my A. So this is A. So notice that A does not have an X component, it only has a Y component, right? There's no part of A that's pointing towards negative X or positive X. So I know then that AX is equal to 0, and all of my A is in the Y direction. So this one's the easy one. AY is just equal to a negative 5 meters per second squared.